Okay. Well, I think we can begin. So welcome, everybody. Thank you for joining us today for a kind of a special community Zoom. I want to take this opportunity to discuss the results of the Decadal Report for the Green Bank Observatory and how we might respond to that report. Before I launch into my presentation, I did want to point out that we have a special call for proposals. We're interested in low frequency, large projects. So check out our website for that special call, and you can see the details there. All right, so to the matter at hand, before any discussion of what Green Bank's opportunities are, I'd really like to highlight some of our science achievements and discoveries that were made in recent months. And this is a kind of an interesting segue into the type of science we do and the type of capabilities we have that will be important to address the priorities established in the Decadal Report. So the first highlight I'd like to show is the detection of the most massive neutron star ever detected. This is with the our pulsar timing ability, and this is kind of cool. This is a neutron star that's so massive it's on the verge of not being possible. We've also done some interesting work with radar, and we're trying to ramp up that capability. So here's a beautiful image of the Tycho crater on the moon, performed with Green Bank. In terms of spectroscopy and galactic structure, we have the ability to detect very faint lines, and this is a line of OH, where we saw a new structure in the Milky Way, a massive structure that was not seen before, a surprisingly large line with that indicates CO dark molecular gas between spiral arms. We're also detecting lots and lots of complex molecules never before seen in space. Here's an example of some of those. And this is a core capability of the telescope as well. And finally, I wanted to highlight this paper that discusses the Sunyaev-Seldovich effect toward galaxy clusters that indicated violent mergers. So clearly we have a very broad range of science topics ranging from the moon to cosmology. So Green Bank has a truly impressive range of scientific topics and capabilities. If I were to summarize the core science, I think I would do it this way. These are the 5 key areas. You may quibble and say that there are more, but these are probably our most capabilities most in demand when we receive proposals. So we'll start with gravitational waves and fundamental physics, and that's enabled by our ability to do pulsar timing. We studied the interstellar medium, star formation, and galactic structure through atomic and molecular spectroscopy and millimeter continuum imaging. We study astrochemistry primarily through molecular line spectroscopy. And as I showed, we do some cosmology and some Yayov-Zeldovich work using Mustang and the millimeter continuum. And we're now expanding our capability to do radar studies of solar system objects. So how does this all relate to the Decadal Report? Well, the news from the Decadal Report is for Green Bank is actually quite good. The Decadal Report established the priorities for the coming decade for the astrophysics community in the US. And the word that they used to describe Green Bank was essential. GBO is essential. There was a broad endorsement for mid-scale projects, and Green Bank in their language would fall as a mid-scale projects, and the funding for mid-scale projects, enhanced funding for mid-scale projects. So that was all very positive. The nanograv project and the pulsar timing capability was singled out as a very important new probe of gravitational waves and a priority for the coming decade. In the radio submillimeter and submillimeter panel report, the ability to measure dense gas tracers was highlighted as an essential element to study star formation. And radio cameras were singled out as an important new technology that GBO can certainly help develop. So all these bode very well for GBO's future and for our place in the nation's astrophysical toolkit. And just like to go over some of those mentions in more detail and talk about some possibilities and options for us and how best to respond to this endorsement, and then solicit some feedback and get a discussion going on your opinions over which of those options may make the most sense. So let's start with the Astronomy Mid-Scale program. This is in section 7 of the report. I'm going to give the section and the page number if you want to look for these direct quotes. But in general, the mid-scale programs were given a high priority by the Decadal Report. They believe that the mid-scale programs can achieve a broad range of science and address targeted strategic goals. And they especially pointed out that this is a way to ensure that the facilities like Green Bank have the best instrumentation and modern instrumentation to maximize the scientific productivity. The major recommendation here was to increase mid-scale funding to $50 million a year. More specifically to Green Bank, the report mentioned that the sustaining instrument element, and that is the NSF should issue calls to solicit upgrades to instruments at public facilities such as Green Bank Telescope, Gemini, and CTO. There was a lot of talk about gravity waves in section L, and nanograv received a lot of mention there. And Green Bank is an essential piece of that project, and probably the essential piece of that project at the moment. What nanograv does, of course, is pulsar timing, and they need continuous long-term timing, and Green Bank is a key facility for that project. Notice that whenever the report mentions single dish telescopes, they mention Arecibo and Green Bank. More on that later. So this is a statement suggesting that Green Bank and Arecibo were provide the bulk of the sensitivity, and now with the sad demise of Arecibo, Green Bank does provide the bulk of the sensitivity for this kind of project. This was an interesting statement that nanograv has sufficient collecting area, but insufficient overall observing time. And so they were promoting the idea of either better facilities, better instrumentation at existing facilities like Green Bank, or new facilities to improve this situation. Next, I'll jump to the radio millimeter and submillimeter panel. That's section M of the report. And the panel gave a very glowing recommendation that Green Bank and Arecibo are essential. And I love that word essential because I agree with it, but that bodes very well. So they did talk about the importance of the GBT for pulsar timing, but they also talked about other high priority science questions and advocated sufficient funding to support healthy fractions of open time. And the question of open time came up. I'll jump ahead here. So what they said was, yes, the funding model for Green Bank may include outside partners, but these outside partners do limit the ability of the observatory to serve the open skies community. And this is a this is a plea to help remedy that situation by perhaps funding the open skies part of the observatory more. Actually, I want to go back here. Yeah, so open skies, open time is essential. Now, the committee also endorsed the ngVLA and radio cameras. Specifically here for pulsar timing, they say radio cameras will add to search capabilities, and the ngVLA will be an important element in the future for pulsar timing. Okay, mention that. This is the recommendation that the observatories, both observatories, here they meant Arecibo and Green Bank, have stable bases of funding. Okay. Section F9 talks about ammonia and N2H plus as dense gas tracers, and Green Bank certainly figures in that with its K-band focal plane array and the Argus instrument. And then they mentioned something specifically about the loss of Arecibo. And they do say that much of what was lost with Arecibo can be replaced in the near term with ngVLA and GBT in terms of pulsar timing, and perhaps increased collaboration with the international community. And they also said that the radar capability of Arecibo played a vital role. And so with the lack of this capability, there is an opportunity here for Green Bank perhaps to pick up some of that slack. The technology of radio cameras was mentioned a few times in the report, and here's the quote where radio cameras and ngVLA will be very powerful in the radio. This was a plea for investment in instrumentation that includes radio cameras. And so to summarize, the Green Bank was mentioned many times in this report, all favorably. The capabilities are highlighted in terms of the importance of Green Bank for pulsar timing. The other key areas that I mentioned earlier as our core science areas. And so I think we fared very well in the Decadal report. And it does present us with some opportunities to respond. So the importance of pulsar timing for gravitational wave studies was a front and center in this report, and that does provide us with some opportunities. So one area would be improved pulsar timing, and we're working toward that. We're building an ultra wideband receiver, and there's perhaps an opportunity here for a higher frequency survey instrument to identify new pulsars that can be used in these timing experiments. So let me first talk about where we are with the ultra wideband receiver. This was a project that's funded by the Mora Foundation. It will work from 0.7 to 4 gigahertz. It's a beautiful machine. You can see the image of the feed horn on the right. It is gorgeous. It will be very critical for future pulsar timing work. It doubles the sensitivity of the GBT for most pulsar timing observation. And it will also be useful in fast radio burst and SETI studies. So the It is now being, it's cooled in the lab. It's cool, it holds vacuum, it gets cold. We'll be testing it in the lab through January. We want to put it on the telescope for preliminary measurements in February, March, and commission in the summer of 2022. And it should be available for scientific use in fiscal year 23. Another opportunity that the Decadal report mentioned was for new radio cameras. And here we have 3 contenders, at least in my mind, that are somewhat developed, or at least the scientific case is fairly clear. One is an Alpaca, which was originally designed for Arecibo. This is a L-band phased array feed, which will provide many beams on the sky, and will be at least 10 times faster than our current single pixel receiver. And this would be used for pulsar searches and low surface brightness, atomic hydrogen, and OH mapping. Argus 144 is a concept for a 90 gigahertz field horn feed array. And this is primarily for molecular line mapping at 3 millimeters, CO, HCO plus, HCN, N2H plus at about 10 arcsecond resolution. And the final one I'll put up there is a K-band phased array feed. This is not a particularly highly developed concept, but based on the success of the KFPA at Green Bank, it might make sense to have a camera at K-band with more pixels on the sky to image ammonia, water, methanol, and other heavy molecules. All right. Another opportunity that we're pursuing here is radar. And of course, with the collapse of Arecibo, Green Bank could fill an interesting role here. And here's a nice result from Goldstone and Green Bank from 2015, where we imaged this asteroid and we found this little moonlet orbiting the asteroid. And it shows you the power of what can be done with the Green Bank radar system. Here's the image of the Tycho crater I showed earlier that was done in March 2021. So this is this shows the ability of Green Bank radar system, even at low power, to discern really fine features on the lunar surface. So this is an opportunity that we're actively pursuing. We are have design work underway. So we're thinking about a high power radar system at Green Bank. We got a Misery 1 grant to do that. We're working with Raytheon to help design that system, and that's going well. The engineering teams are now developing conceptual designs to show its commitment to this project. NREO and GBO have formed a joint radar division within AUI and hired our director, Patrick Taylor, who many of you might know. Patrick is at LPI now, but was at Arecibo and is an expert on radar systems and solar system radar imaging. So at the current stage, we're looking at a design and technology development and thinking about how best to deploy a radar system to Green Bank. The current concept calls for actually a new secondary mirror that would be folded in front of the current Gregorian secondary. And finally, I want to talk about the ngVLA. ngVLA got a ringing endorsement from the Decadal report, and Green Bank would be a station for 3 of the ngVLA antennas. This is exactly how it would look like. The current array configuration does call for Green Bank as one of the kind of the longish baseline stations. So Green Bank will host ngVLA antennas. The current plan is for 3 of them, and will help develop that system. In addition, the GBT could play an interesting role in the ngVLA. It could provide that large collecting area element that is sometimes necessary to get the adequate sensitivity at the long baselines. And with array cameras like, I don't know, the Alpaca or Argus, you could imagine Green Bank providing zero spacing flux for large scale structure and ngVLA images. So what are the next steps? So the Decadal Report has established these priorities, and the GBO's capabilities are essential to many of these science goals, and has been singled out specifically as important for continued funding. So I think Green Bank's future is quite secure, and now we have to decide what to do. So we will seek your advice in the community to advance our plans and figure out the best science we can possibly do. And as steps along that way, we will be hosting lots of workshops. We will be hosting advisory committees and community review panels to solicit feedback. We will be at the Winter AAS. I just registered today, so please stop by our booth and find us to give your feedback or contact us at any time. Here's my email address. Please note that my email is jmjackso, not Jackson. So I don't know why, but that's what we have. And I'm happy to look at your comments and discuss with you our best response to the Decadal Report. I think we have lots of opportunities, but we rely on you, the community, for proper guidance. So to summarize, Green Bank got a glowing endorsement in the Decadal Report. It's an essential facility, and the report recommended sufficient funding, particularly to maintain and improve its capabilities for open skies. Pulsar timing was especially called out, and the report recognizes that the loss of Arecibo makes Green Bank especially important. The technology development and radio cameras was highlighted, and that is an area that we can certainly contribute. And options for improvement include Alpaca, Argus, K-band, phased array feed, and radar. And so with that, I'd like to open the discussion. I'd like Jay and Dave to say a few words and then open the discussion to the community. So Jay, do you want to go first?
Sure, thank you. I don't really have anything to share on the screen, but I might say that one interesting capability, which has kind of been developed, not quite underground, but is only coming to fruition now, is 3mm VLB. And there's a relatively small community that's working on it now, but with ALMA and with the LMT, the GBT has approximately the same point source sensitivity as ALMA at 3mm, and it's extremely powerful. And I think the community is beginning to appreciate this. We actually have a question here. Will the GBT be collaborating with the Event Horizon Telescope team? And in fact, there is a group from that team which has been developing and using the 3mm capabilities of the GBT. And the results so far have been extremely impressive.
Anything else, Jay?
No, I think you summarized it quite well.
Okay.
Yeah, I agree.
Thanks for pointing that out. And I would be open to that. Absolutely. I love the Event Horizon Telescope, and it would be great to participate in that project.
Just to follow up on the Event Horizon, I mean, it primarily does 1mm observations, not the 3mm observations, just for clarity. But as Jay says, with correlating with ALMA at 3mm, with ALMA as well as potentially the LMT and stuff, 3mm VLB with the GBT. It's quite exciting future. We have a couple other questions. Well, I'll just put in my, I thought Jim did a good job summarizing everything. There's a couple aspects that I found additional points that I found interesting. They explicitly in a footnote say they recommend to maintain a healthy fraction of open skies. They actually put a percentage in there, 50 to 60%. So I think we can certainly leverage that as we try to get partners and the compromise between the NSF and our partners. So I think that's encouraging. It gives us, I mean, the justification for arguing to maintaining our current level of open skies time. Another aspect I thought was interesting earlier on, I think in the report, was highlighting the importance of data archives and science data ready products. I think that potentially those points within that decadal survey might that's going to impact potentially a lot of our internal priorities and what we do at the observatory for our user community, which I think is well justified. We are a little bit lacking and deficient. I think we would all agree in those fronts right now. So there's a lot of room for improvement there. So that was which isn't too surprising, because they for radio astronomy, they keep saying at radio observatories, including like the VLA and ALMA and the ngVLA, we have to make these products easier to use. So that's going to be interesting as people argue for resources and all observatories for that. I can just the Vera Rubin telescope, for example, and all these other telescopes will be looking for resources in that area as well. But it opens up for us as well to look for resources, or at least help guide our priorities internally. We have some questions here. They're not in order. Do we? Jim, do you want to take these questions? Or
yeah, I'll take the first one. So the first one I see is from Steve Crofts. It says the search for life was prioritized in the decadal, although mostly biosignature searches. Technosignature searches with breakthrough listen make up 20% of the time at GBT. Do you see other opportunities to tie into the search for life? I do, actually, and this is an important question. If any project on the GBT is going to make the most significant discovery in our lifetime, it's probably this one, if they are successful. Breakthrough Listen does a fantastic job, and they have a very strong and multi-pronged approach. But we would entertain other proposals, even large proposals, to study this important area. So this is mainstream science. This isn't fringe by any means. So we would welcome proposals in this area. And if the proposal passes muster through the TAC, we will be happy to work with those teams. Question about, was there any consideration of funding to rebuild Arecibo in the future? The committee didn't recommend that. So I don't know really the answer to that. There was some talk about adding new facilities to Arecibo, smaller dishes, smaller arrays, and that may well happen. I don't think it is in the plans to rebuild Arecibo as it was constituted. That's major effort. Question from Sue Ann. What do you make of the many mentions of AO alongside of GBO? I make that the report was written before the Arecibo collapsed, and then they had to add a paragraph recovering. So, that's a bit of a flippant answer, but both telescopes provided important single dish capabilities. Green Bank had less collecting area, but could work has a better surface, and so could work at higher frequencies. And I think in those senses, the instrumentation was complementary. And of course, Green Bank is fully steerable, and Arecibo was not. So Green Bank could look at places on the sky where Arecibo couldn't. In some sense, FAST is picking up some of the slack from Arecibo, and it has a very large collecting area as well. And we are complementary in the same sense to FAST. So I think the mention of Arecibo alongside GBO is just highlighting the importance of single dish astronomy and the important research that it can conduct.
Jim, if I may break in with a comment
Sure.
here on a slightly different topic, because it's pretty clear when the Rubin telescope gets operating routinely that there will be a demand for follow-up observations in the radio. And so the GBT is certainly well positioned to supply that to the community. The question of how that is scheduled, how that should fit in with our priorities is something that we're going to need to discuss with the community in the coming years.
Yeah, that's a very important point, Jay, and I did overlook that in my presentation, but it hasn't escaped me that in time domain astronomy, every observatory is going to face this issue, right? The Rubin telescope is going to discover dozens and thousands of time variable sources, And then I guess the question is, you know, how do you sift through all that data and prioritize when the Green Bank telescope slews to them and interrupts the current observing program? You know, when, you know, for the LIGO results, of course, every telescope in the world that could was pointed at that spot in the sky, and for good reason. When these time variable sources become routine, we're going to have to find a way to prioritize and do that. And you can imagine several schemes, like, you know, you could have some sort of filter where if it's like a super interesting event for that where the radio data are key, you could interrupt and slew. And so you'd have to develop algorithms to make, you know, to make that call of what is like a prime event. The other possibility you could do is say, okay, I'm going to allocate a few days to look at everything that Ruben found the day before. And, you know, if they find, you know, dozens or hundreds of sources, that should keep your telescope busy for a day or so. So, you know, there are various possibilities, and we'll just have to weigh which makes the most sense scientifically.
We've got a couple more questions.
So one is, what's the expected timeline to decide what would be the next instrument to build? Look, we want to respond fairly quickly here. But the reality is that these projects are in different stages. So Alpaca has gone through a design review and is about halfway through its funding cycle, and I think some hardware has been made. So Alpaca, which was designed for Arecibo, could be an interesting instrument to come to Green Bank, and that would be probably the shortest time scale because it's already in development. But there's still a lot of work to integrate that camera into the Green Bank system. Argus, I think, is a very mature concept. I don't think there are any technical showstoppers there. It's just packaging the arrays in a small enough area, but it's millimeter array receivers have been built for a long time now. So there's nothing particularly technically challenging about that, except for the size of the array. So I think that could be built in a five-year time scale, and we tried to get funding for that before, have not been successful, but we've been close. So I think the ability, if we decide to go with Argus, we may repropose next time the call comes around. The K-band focal planar, the phased array feed, the K-band phased array feed is new and has no real development other than lower frequency equivalents. So that probably would have a longer time scale. Now, when we have to decide on these things, well, the sooner the better, but I would like to get some of the community input and make some decisions in the first half of next year. Okay, another question here. What's the current RFI situation, especially the increasing number of satellites and crowding of the communication bands? Great question. We are investigating it. Chris Dupree is now working at NRAO and is working with us to work with industry on what's it called? NRQs, dynamic. There's a dynamic NRDQ or something. Anyway, he's working with industries to see whether we can come up with some solutions to share the spectrum gracefully. We are working on a RFI monitor here at Green Bank. I would really like to move that project along and understand the scope of the problem. I guess we do have the data we do RFI scans with whatever instrumentation is on the telescope, but I have yet to see an analysis of that. So it's something we will address, and I hope to have the answer to you in a few months. Here's one from Gary Cole. How will the future of high power radar at GBT compare with the capabilities of Goldstone for asteroid image? We're in the early days yet, but okay, Marty has the answer. So Marty, if you want to.
Actually, I'm just ticking these questions off as they come up, so I don't have the answer. Thank you.
Oh, okay. Okay. All right. All right. It really, so we're in the early days. I don't know whether how powerful a system we would have, but it would certainly be as we're hoping it would be as capable. Now, of course, if we add more collecting area on the receiving side, the combination of a green bank telescope transmitter at, say, I don't know, 0.5 megawatt, and the ngVLA as the receivers, that would be a very powerful radar system indeed, and would be better than anything that's ever been used. What's the expected peak power for future planetary radar upgrade? Yeah, that's in the design stage. We're looking at 0.5 megawatt ish, to be determined. All right. How would GBO balance high frequency versus low frequency observations following the decadal? For instance, would breakthrough listen be prioritized even in high frequency weather? Interesting point. Our dynamics, so we do have an interesting capability at high frequencies. But for us, high frequencies means up to 3 millimeters, right? So up to 100 gigahertz. We do prioritize the best weather for high frequency observations because it's much more critical for those observations. And we tend to do our lower frequency observations in poorer weather, where it doesn't affect the observations nearly as much. So, from my perspective, this will be a function of proposal pressure and demand. Right now, the high frequency observations are far more oversubscribed than the low frequency observations, and so they get the priority. All right, next question. Given the greater truly scientific demands on the GBT connected with the demise of Arecibo, is parting with Breakthrough Listen considered? Not at the moment. Breakthrough Listen has been a terrific partner for us, and we consider their science absolutely a key part of our mission. So no, I'm not considering breaking with Breakthrough Listen, at least in the near-term future. I mean, I think that partnership is working very well.
We have a question that's come in through the chat. Could the Alpaca digital backend beamformer be used to support a K-band PAF?
Oh, that's an interesting question. I would imagine. I mean, I don't know of any showstoppers there, but I'd have to ask the engineers in the room. Dave, do you have any comment on that?
I think that it's a very similar technology. I don't know how they're planning to configure the Alpaca beamformer back in, but yeah, I mean, in principle, the technologies would be very similar.
All right.
And we just had somebody chime in, the beamformer backend would be able to support it. Additionally, with RFI mitigation. Came in from Mitch Burnett, who might be part of the
Thank you, Mitch.
Alpaca.
Thank you for that. All right. Any other questions or comments? So I just would like to say that, thank you for your attention here. I think the report was really good for Green Bank. I'm heartened by the endorsement. I think it bodes well for a secure future for Green Bank. And it gives me great solace that that's one battle we don't have to fight. So it opens up a lot of possibilities for us. And in the future, please consider that if we tap on your shoulder and ask for your opinion or your help in some of these panels or workshops, that you do take some time and help us out, because we really rely on the community to establish our priorities. And we want to build what you guys need. So help us help you by participating in these various advisory panels, workshops, and review panels.
We did get an additional question in the Q&A.
Okay.
And is there a discussion of an upgraded spectrometer to match the arrays to be developed?
That's a great question. So of course, if we're going to go to, say, I don't know, a K-band path with, I don't know, what's the number of elements, Jay? Something like 60, 80 beams, maybe 90, something like that. Our current spectrometer can't handle it. So we would consider that back-end development as part of the instrument development. And it may be the same for these other instruments, maybe not quite so much with Alpaca, but it depends on how much bandwidth you want, right? So, if we have to process a lot of bandwidth with a lot of array elements, then yes, we would need to develop backends that are capable of supporting those. So it doesn't make much sense to have a K-band phased array feed that can only look at one of the hyperfine lines of ammonia. So that would be considered as part of the instrument development. And it could be a separate development designed to accommodate all these instruments, but you're looking at a pretty spiffy correlator / backend.
Yeah, I'll just chime in terms of like with Argus 144, we would certainly had to propose to include the back end capabilities. And this is again where our community input will be very important between the trade-offs between the number of channels and bandwidth will come into play. Certain astrochemistry projects, they want bandwidth to do the surveys really quickly. If you're trying to map a large area, you want to throw as many beams on the sky as possible, and bandwidth isn't necessarily as important. So that's where we really need the community input to help, set our priorities.
Oh, and Sue Ann did mention it's the NRDZ, the National Radio Dynamic Zone. Is that it? So Jay, any last words?
No, I think that's about all for today.
Okay. Dave, you want to chime in with a last word?
No, we had good attendance here. So thank you, everybody. We had 60 people on top of the 4 panelists.
Great. So I do thank you for your time and attention, and let's move forward together. I'm very heartened and very optimistic about the GBO future.